Hi everyone, so welcome to another video where I'm going to teach you how to test ceramic capacitors using the multimeter. We're going to see how to test ceramic capacitors in the laptop motherboard using the multimeter and also in the tablet motherboard. To test the ceramic capacitors, we're going to select, as you can see here, the continuity option. Okay? But before diving into the details, make sure you subscribe and click the notification bell to stay updated for future videos like this one. This is basically the ceramic capacitors that we're gonna test using the multimeter. So I want just to see that you can find many types of ceramic capacitors in laptop motherboards and computer motherboards. For example, you can find this kind of ceramic capacitors, big ceramic capacitors. Also here we have other ceramic capacitors, as you can see over here. Okay. So let's begin and test, for example, this big capacitors over here. So we can just put one probe here, okay, and the other probe into other terminals. Do you see? We get a reading here in the multimeter. We should not get a reading like this, a 0 in the multimeter. So let's check the second one over here. Okay, we have here the same reading. So these capacitors are good. So I want to add here that, for example, this capacitor is not like this one in terms of size. So if you have, for example, a failed capacitor like this one, you should replace it with another ceramic capacitor with the same size and same color, because above ceramic capacitors we don't have here values like, for example, tantalum capacitors or electrolytic capacitors. That's why if you find a failed ceramic capacitor, you should replace it with another one with the same color and same size. This, for example, and this are same, okay? But as you can see here, this one, for example, and this one are not the same. This is a brown color, and this color, as you can see, is not like this one. Those also over here are not the same as this one. So, for example, if this one is failed, do not replace it by this one or this one. You should replace it by another one. For example, these two are the same. These two here are same. So this is how you can replace ceramic capacitors. Here also, as you can see, if, for example, this one is failed, we can replace it with another one with the same size and same color. But for example, do not replace this one by this one. Enter the processor directly. We have ceramic capacitors, many ceramic capacitors. So let's check any ceramic capacitor. Let's check this one, for example. Do you see we get in the multimeter a very low resistance? Let's check this one also. As you can see, this is a short. No, this is not a short. I will prove to you. So let's go directly and remove the processor. As you can see, now the processor is removed. Okay, so let's check again the ceramic capacitors. So this is the two ceramic capacitors that we have test. So let's test it again. So one probe here and the other probe here. Do you see in the multimeter? We get 700. Let's check this one also. 700. Okay. If we put back the processor, no, the processor is installed. So let's check again, just to make sure. Just to make sure. So one probe here, the other probe here, as you can see in the multimeter. We get a short. This is not a short. So please, guys, remember, always for chipsets, okay? Always for chipsets like the CPU, the graphic card or North Bridge, and the ICH. Always the ceramic capacitors, as you can see, that you're gonna find in the back of the chipsets you will usually, not usually, but always, you will find a very low resistance. This low resistance is not a short circuit. So please remember, because many technicians find like this short and try to figure out where is the short circuit exactly, but no short, it's not the short circuit, it's normal. But for the ceramic capacitors that are not belong to CPU circuit or other chipset circuits, you will find a normal reading, as you can see here. For example, do you see? Normal reading. Okay, any ceramic capacitor here, if I find, for example, here a low reading, means we have a short circuit. So I want to add here that you will find ceramic capacitors around every integrated circuit, as you can see here. Do you see the ceramic capacitors? That's why the ceramic capacitors are very important. Okay, do you see? Here we have IC, here we have ceramic capacitors. Now I have a question. Before testing the ceramic capacitors, I have a question. What is exactly the purpose of these ceramic capacitors? So please do answer in comment below. So do you see here, for example, we have the SIO, the super IO, we have ceramic capacitors. Okay, we have this IC ceramic capacitors. So for the chipsets, so in the back of every chipset, as you can see here, we have ceramic capacitors. So the same as you can see for the tablet motherboard also. Do you see for tablet motherboard? Okay, we have over here, we have ceramic capacitors, as you can see. And for every IC, we have this IC, for example, we have ceramic capacitors, as you can see over here. So let's now test the ceramic capacitors using the multimeter. So as you can see here, for example, this is many ceramic capacitors around this IC. This is a control IC. So basically, a failed capacitor is the capacitors that is shorted in both sides. Okay, so if we check the capacitor and you get in the multimeter like this, means the capacitor is shorted. Okay, so let's take this one, for example. Here we get a reading. So this capacitor is good. Let's check this one here. This one also is good. Here, do you see? This one also is good. So these capacitors are good. So let's check these two, for example. Two over here. This is a good capacitor. This is another good capacitor. Okay, so just using the continuity, you can check whether the capacitor is good or not. So sometimes you can find, for example, a shorted capacitor over here, and even if the capacitor is shorted, the problem is in the IC near to it, not the capacitor. Okay, because when the IC is shorted, the capacitors around it also will be shorted. Why? Because these capacitors are connected to the IC. Okay, I will draw the schematic for you, but please, here I have a note. Sometimes you can find other component like this one, for example. Do you see this component? This component is like a capacitor, as you can see here. We have here L, but this is not a capacitor. This is inductor or coil. Okay, the reference here for inductor is L, but for capacitor the reference is C. Okay, so if I check this inductor, I will get a continuity in the multimeter. So let's check, as you can see. So please pay attention. This is not a capacitor, this is inductor. Always the color for inductor is black and the capacitor is brown. So I hope so that we find a shorted capacitor here, a shorted capacitor in the motherboard in order to understand clearly. Here, for example, we have two capacitors. This is B capacitors. Let's check it. This one is good. The second one is good. The second one also is good. So here I have a question. For example, if you find this capacitor is shorted, we don't have here the value of capacitor like the electrolytic capacitors. So how can you change it? So to replace the capacitor, for example, here, this is a ceramic capacitor, and this one here also is a ceramic capacitor. But in terms of size, these two capacitors are not the same. So for example, if you have a failed capacitor like this one, you have to replace it with another capacitor with the same color and same size, regardless of the value. Okay? Because ceramic capacitors in the motherboards, you cannot find the value over the ceramic capacitors in the motherboard. Okay? But for this one, for example, you cannot replace this one with this one, for example, or this one. No, you should replace this one with another one, with the same size, same color. Okay, so regardless of the terminals. So this one is not polarized capacitors like the 10 ohm capacitor and electrolytic capacitor. As you can see here, for example, for the electrolytic capacitor, as you can see over here, okay, here for example, this is electrolytic capacitor. We have here plus and here we have minus. This color means minus. Okay, so plus minus. But for ceramic capacitors, it's not polarized capacitors. Also for 10 ohm capacitors, as you can see here, we have over here 10 ohm capacitor. This is basically 10 ohm capacitor, this one. Here we have plus and over here we have minus. Positive terminal and the negative terminal. So let's see this motherboard, for example. As you can see here, we have 10 ohm capacitors over here. So these two capacitors, as you can see, these capacitors, we have the positive terminal here and we have the negative terminal over here. Okay, so let's see this motherboard. Also we have here some capacitors, ceramic capacitors. As you can see, the reference we have C. So let's check. This is a good one. This one also is good. This one also is good capacitor. Okay, and here, and I will add here a tip that all ceramic capacitors are connected to the ground in one side. So let's check this one, for example. As you can see, it is connected to the ground in this side, and this side is connected to the MOSFET. This one also connected to the ground in this side. This side, no. This one also connected to the ground in this side. Okay, so here, as you can see, we have the trace. This part, as you can see, is connected to the ground. Here, I made a video about how to track signals in the motherboard. Always try to use this part in the motherboard. Okay. So now let's check some ceramic capacitors into tablet motherboard. As you can see over here. Here basically we have some ceramic capacitors, as you can see. So we can test it using the same working principle. As you can see here, let's check this one. Do you see? No short. This one also is not shorted. This one also is not shorted, means these ceramic capacitors are good. So remember, to test the ceramic capacitor, you can just use, as you can see here, the continuity option. Here, the continuity option in the multimeter. So the symbol for the ceramic capacitor is this one. Okay, it's not polarized capacitor. This is basically the ceramic capacitor. But for electrolytic, okay, capacitor, its symbol is, as you can see, this. We have here plus. Okay, or you can find also this symbol. This also means minus. Okay, so to test the ceramic capacitors, you can use the continuity option in the multimeter, and you should find a reading that is higher or equal 60, we can see ohm in the multimeter. If you find a 60 ohm in the multimeter, means the ceramic capacitor, okay, is good. But in the CPU, as you can see, circuit and GMCH and also ICH, okay, circuit, you can find the value is greater or equal 0.003, okay, and 20 ohm. Okay, so if you find 0.03 or 0.04 or even sometimes 0.02, it's okay, it's not a short circuit. If it's the CPU, if you can remove it and check, it will be better. But if the chipset is integrated, anyway, a low value doesn't mean a short circuit unless you find 0.003 zeros. If you find 3 zeros, means automatically you have a short circuit. Then we have seen that if you find, for example, a ceramic capacitor, a bad ceramic capacitor, this is, for example, you find this bad ceramic capacitor, you should replace it with another ceramic capacitor with the same size, okay, and same color. Okay, same size and same color, because above the ceramic capacitors you cannot find the value unless you have the schematic. If you have the schematic, then you can find the value of ceramic capacitor. This is an example, as you can see over here. This is a ceramic capacitor. We have the schematic. Here we have 4.7 microfarad, 25 volt. Okay, as you can see. And for this one we have 10 microfarad, 25 volt. So if you have the schematic, as you can see, you can find the value of any component you want. So, and as I told you before in the previous videos, so this is basically an IC. So next to each IC you will find many ceramic capacitors, as you can see over here. Okay, many ceramic capacitors. So the ceramic capacitors are always connected to the ground in one side and connected to the IC in the other side. That's why if you find, for example, that these 3 ceramic capacitors are shorted, means the IC is shorted. Around every IC in the motherboard, as you can see here, this is basically IC. So around every IC you will find some ceramic capacitors, as you can see. Always the ceramic capacitor is connected to the ground in one side and connected to the IC in the other side, as you can see. We have here another, as you can see. So basically here, for example, we have C1, C2. Okay. So when you find, for example, this capacitor is shorted in both sides, means automatically the IC is shorted to the ground, because as you can see here, the IC also has many pins that are connected to the ground. So when you find a shorted capacitor, it could not be the capacitor that is short, no, the IC. Okay, and of course to check the IC, to check whether the IC is 100% the failed component or not, you can just use 3 methods. Okay, you can use 3 methods. Okay, so the first, the second, and we have here the third. So the first method is by checking the head. Okay, the head of the IC. For example, let's assume that we have this IC, for example. Do you see here? This IC, for example, if we check this ceramic capacitor and we find shorted capacitors, we can just check the heat of the IC using my finger like this. If the heat of the IC so is not normal, if the heat is not normal, is very increased, means automatically failed IC. Okay, so the second method is by checking, as I told you before, the ceramic capacitors, okay, or PF, we called it also PF capacitors or picofarad capacitors. If you find any shorted capacitors in both sides, means the IC is bad. So the third method is by checking the inputs and outputs. For example, here we have this IC over here. So here we have VCC, okay? And here we have enable signal. These two are inputs. And basically this IC will generate an output. Let's say, for example, 3.3 volts. So if you don't find 3.3 volt in the output, you should go back and check these inputs. So to check these inputs, basically we need the schematic, okay, the schematic or the data sheet of the IC. So thank you very much, guys. This is all for this video. So don't forget to like the video. If you enjoy it, subscribe and share the video with other people like you. And of course, for anyone who wants to join me in my Patreon page, you are very welcome. As I told you before, I can be your mentor. If you subscribe to mentorship experience, I can be your mentor and assist you repairing your computers. Thank you very much and see you in the next video.